Hey guys, in this video we're going to be reviewing total area under the curve. The really important word there is total. Anytime you see that, you need to really take note of it, highlight it, circle it so you don't forget it. So in the first example, I just have a picture. It says find the total area under the curve f of x, which is this graph from 0 to 30, so starting at the origin, ending at 30. If we had to find the total area there, you basically ignore any negative area. You really just consider it all positive, even if it is under the x-axis. So here we would just do 10 plus 10 plus 10, and the total area would be 30. All there is to it. You might have to do total area as well, just given a function. Find the total area under g of x from 0 to 3 pi over 2. If you did that, when you see that word total, when you set up your integral, all you have to do is include absolute values. Absolute values, our function is sine of x dx, and that will make sure that you're counting all area as positive area, even if there is some negative area. All right, so all you'd have to do is type that into a calculator. Let me get my calculator here. Try to hold it so you guys can see it. But if I zoom in like that, you guys could probably see it. If I press math, it's not a very good picture. I need to get a good angle there. All right, that's probably okay. All right, we're doing the integral from 0 to 3 pi over 2. We need absolute value signs in there. Type in our sine of x, put our x in there, and we get our answer is about 3. All right, you guys could round that to 3 and can get by. And again, that just takes all area there. Even though some of it would be negative, it takes it all and just counts it as all positive area for total area. All right, so those are really easy examples. Now to something more like what you might see on the AP test. This problem says a high-speed monorail is traveling back and forth on an east and west track. So picture a train that's just moving backwards and forwards, east and west. It says the velocity for the time interval 0 to 60 minutes is recorded below. Notice that some of the velocities are positive, some are negative. If you think about a compass on a piece of paper, north is up top, east is to the right, south is bottom, west is to the left. Since east is to the right, east is probably your positive velocities, and west is to the left. Those are probably your negative velocities. So for example, at a time of 15 minutes, the velocity of this monorail is 10 miles per minute, but it's just traveling west since it's negative. All right, at 60 minutes, the monorail is going 25 miles per minute. That's its velocity, but since it's positive, we know that it's traveling east. So those negatives and positives kind of give you a hint on what direction the train is traveling. So in part A, I have a question here. It says approximate the integral from 0 to 60 of v of t dt with a left Riemann sum. All right, with 5 subintervals. So that should be easy. I would draw in those subintervals. This is 1, 2, 3, 4, 5. Down here I draw them in 1, 2, 3, 4, 5. All right, so we're ready to set up our integral. Again, it's approximating this. So I might just write that integral from 0 to 60 of v of t dt is about, just to show that it's approximating that. All right, so now if we get started on our Riemann sum, our first rectangle is 10 units wide. All right, our next rectangle is 5 units wide. The next one, 15 to 30, is 15 units wide. 30 to 50 is 20 units wide. And the last one is only 10 units wide. All right, let's make sure you guys can see all that. Then we have to put in how tall each rectangle is. Since we're talking about a left Riemann sum, we're going to take all the numbers on the left of each of these boxes. So 0, 20, negative 10, negative 35, and 10. You really just leave the last one out on the right since it's a left Riemann sum. So we can put those numbers in 0, 20, negative 10, negative 35, and 10. If we put those numbers in, we could put that in a calculator And I believe the answer works out to be negative 650. All right, so that's the answer to the Riemann sum. But then it said explain the meaning of that integral. So we have an answer, we have this integral, we have to talk about what this negative 650 means. So I would really try to figure out the units. Think if we're talking about the area under the velocity curve, we could draw kind of a quick picture and think about what the units would be under that curve. That's one way to think about it, or we could talk about another. So I might just draw just kind of a hypothetical graph. I don't know what this graph looks like. I might just say, let's pretend this is our graph of v of t. All right, we know the x-axis should be labeled with minutes. The y-axis, our velocity, is miles per minute. And think about for your area under the curve, you'd have to multiply those together. The minutes would cancel. You'd really end up with miles. That area under the curve just represents miles, or really distance, the distance that the monorail has traveled. And usually, if we go back to here, this integral, if you're talking 0 to 60, it's usually the change in the position of this train. So first of all, negative 650, it's negative. That means 650 miles, but we're talking west. All right, and that's really the position of the monorail. It went 650 miles west of where it started. Basically, it's how it changed on that interval 0 to 60. So they never told us where it was at a time of 0, but wherever it was at a time of 0, it is now 650 miles west of that point. All right, so how we could explain it, we could say that the integral from 0 to 60 of v of t dt represents the change in the monorail's position on the interval 0 to 60. And you should say that that represents minutes. All right, you could get away with that explanation. If you did want to go further or really just understand what's going on, you could say that at a time of 0 minutes, they don't do that. I would probably just stick with that. And position, right? We talked about if this is velocity, the antiderivative of velocity is position, so that should make sense why that represents position. But again, it's really just how that position, how it changed. From a time of 0, we didn't know where it was. From that time, at the end of those 60 minutes, the train is now 650 miles west of where it started. All right. Part B, now it says approximate integral from 0 to 60 of absolute value of v of t dt. You guys know absolute value really just means total area we're talking about. So maybe really emphasize that we're really talking about total area, that when we do that Riemann sum, we're still supposed to use a Riemann sum with 5 sub-intervals. We're really supposed to think about all the area being positive. So if you kind of go back to think about each of these, every time we multiplied, that really represented the area of one rectangle. These two right here would have been considered negative area because they had negatives. So really how we can change it to all positives is really just ignore these negatives. Call this positive 10, call that positive 35, and that will get us that total area. So we could write that out. Not much is going to change there. If we do 0 to 60, absolute value of v of t dt, it's going to be the same, 10 times 0 plus 5 times 20. I'm just copying from up here, plus 15 times positive 10. Instead of negative 10, make it positive 10, plus 20 times 35, plus 10 times 10. You just want all area to be positive there, and we could type that in a calculator to figure out what that is. Give me a second to calculate that. And I got 1,050. Right, so think we just took basically total area under the curve. All that negative area was really just considered positive area. And if we had to explain the meaning there, all right, think about what that means. This is still in miles, right? We're still talking about area under the same curve. It's miles there. And it's really just going to be the total miles that this train has traveled. It's no longer the change in position. It is literally how many miles it has covered. So we can say let's actually state the integral from 0 to 60 of absolute value of v of t dt represents the total distance the monorail traveled on 0 to 60 minutes. Remember, you want to be very specific. Definitely mention units. We could probably improve this by saying represents the total distance in miles that the monorail traveled from 0 to 60 minutes. This monorail is going back and forth. It's traveling east, west, going back and forth. In total, if you added it all up, it would have gone 1,050 miles. All right? So that's kind of the difference between when you have absolute values and when you don't. All right? Hope this helps.